We're going to review factoring polynomials, but first let's get some vocabulary reviewed. So the first expression here is a polynomial, and the degree of the polynomial is the highest power of the polynomial. So this polynomial has a degree of 2, which means that we call this a quadratic. And it has 3 terms. The terms are the expressions, that's one term, the expressions that are separated by plus signs. So the negative 2x is a term and the 4 is a term. So this has 3 terms, and therefore we call it a trinomial. So this is called a quadratic trinomial. The next one is a polynomial as well. And this is, we've seen that this has just a degree of 1. So this is a linear, that's the name for it. And this thing has 2 terms. This is one term, this is another term. Oh, wait, this is another term. So it's a linear binomial. The next one is a polynomial as well, and it has a degree of 3, so it's a cubic binomial. And the last one is not a polynomial, and here's why. That term is not an integer power of x. Like integer power of x would be like x cubed or x to the 4th. This one happens to be an x to the 1/2. You may have remember that from last year. That's not an integer, so it's not a polynomial. The most fundamental form of factoring is taking out common factors. Here, this first expression has a 2 in it. The 6 and the 18 both have 2s, so we can take out a 2. So we divide. It's taking out is really dividing out a 2. So 6 divided by the 2 gives me the 3x squared. But they also have something in common here with, they also have some x's in common. So let's take out some x's. And we take out 1x here. So if we divide by x, we're essentially dividing by x. So one of the x's cancel. We only have 1 left. Here, if we divide this term by x, the x's cancel, we get 3x plus 9. You can always check your work to see if you did it right by multiplying it out. You know, a distributive property, multiply it out and see if you get the original expression. So the second one does have a 2 in common for everything. But isn't it kind of weird to have the x squared term at the end? The reason I want to move that around, but with that negative sign there, I like to have the leading coefficient. That's a coefficient on the term with the highest degree. I want that to be positive. So instead of just taking out a 2, let me take out a negative 2. So if I take out a negative, we already took out the 2. So if you take out a negative, it's like dividing by negative 1. So everything just changes sign. So dividing by a negative, same thing as multiplying by negative 1. Divided by negative 1, I just took out a negative 1. And so now we can start moving things around. This 4x squared will move to the beginning. We'll leave the 3x there. And this is called standard form when things are in order the way they should be. So whenever I see things in a weird order with a negative, I take out a negative as well. Now this last one is kind of weird because what they have in common is everything in this parentheses. So we can actually take that parentheses out of each term. We can take out an x minus 2, and let's see what we have left. I don't need the square brackets, it could be round, but what we have left is, if you take out the x minus 2, we have 3x minus 8 left. So that's how you factor it. let's factor trinomials. But to do that, what I want to do is look at the direction where we multiply, because factoring is pretty much, well, unmultiplying. So let's use FOIL, x squared, 5x, 3x, 15. And the reason I'm showing you this is it kind of shows what's happening, that when you FOIL out, the O's, the O and the I, usually can be combined. So we have x squared plus 8x plus 15. So if we want to unmultiply this essentially, which is called factoring, the biggest clue that we have to work with is this 15. That comes from the 3 times the 5. So if we know that that's 15, we know it's got to have some 3s and 5s, or maybe a 1 and a 15 in there in the answer if we're going back this direction. So this is the biggest clue. And the next biggest clue is that 3 and the 5 add up to 8. Okay, so if we go to the next step, this is our biggest clue. And we have to find numbers that add up. Well, first of all, let's find numbers that multiply to get 12. I like to do factor pairs, so I do 1, 2, 1 and 12, 2 and 6, 3 and 4. So those are all my choices. That's all I have to work with. So now the next clue is going to be which ones of those pairs add up to get 8, right? So we can see that the 2 and the 6 add up to 8. So let's finish the problem. We know we have to have a 2 and a 6. And they add up to 8, positive 8, so it's plus and plus. That's how you factor. If we have a negative sign, the process is still the same, but things get a little bit harder to see immediately. And this last one is minus 12. So once again, our clue here is that we have to multiply 2 numbers to get a negative, which means that one of the numbers is going to be positive, one of the numbers is going to be negative. Here, when we add these 2 middle terms, this is a little bit, this kind of hides things a little bit, but that's if we multiply. Let's go backwards now. Okay, so 24 still has, this one has lots of factors. So 2, 12, let me see, 3 goes into 24 8 times, 4 goes into 24 6 times, so those are all my factors. If I list the factors, that helps me see which ones are the ones I need, because if these will multiply together to get 24, if I have one of them, negative 24, if I have one positive, one negative. So we got to make sure they add up to negative 5. And the way we're going to do that is get a negative 8. And so now a negative 8 plus a 3 will give me the negative 5. So now I know what to do. Plus 3 minus 8. And then once again, you can always multiply this out and see if it works. There is a special case. If we multiply something that looks like this, these 2 middle terms, one's a positive, one's negative, they all go to 0. So we just have x squared minus 49. This has its own name. This is called the difference of 2 squares, because the first term is a perfect square, x squared is a perfect square, and 49 is a perfect square, and the difference is the difference, the subtraction. So that's a common form that we're going to look at, and it really just comes from just the fact that the OI, the outside and the inside terms, cancel. So this example here on the right does not look like a difference of 2 squares. That's not a perfect square, neither is that. But don't forget, we can factor out a common factor. They both have a 2 in it. Now this is a perfect square. We have x squared is a perfect square, 25 is a perfect square, so we can factor it. You can also just think of this, let me show you this. You can also just think of this as 0x minus 25 and just factor this the same way we did before, where you just think of this as a trinomial, 2 things that multiply to get 25, well, negative 25, and then they add up to get 0. So you don't have to memorize anything new. But this whole thing happens frequently enough that it's worth just memorizing the pattern, just jumping to the answer instead of working as a trinomial. We just realized that this really is x plus 5, x minus 5. Okay, things get a little bit trickier if the leading coefficient of one of the terms, one of the factors, is not 1. So if you have 3 there, watch what happens. 3x squared, that part's okay. Oh, look at that. The 3 is multiplied by the 5, so now we get 15x. And 2x. And then 10. So 3x squared plus 17x plus 10. Now look at our clues. The 10 is still a good clue. That came from the 2 and the 5. But the next clue, the 17, 2 and the 5 don't add up to 17. Here's why. The reason they don't add up to 17 is that 3 got in the way. The 3 was multiplied by 5. So 3 times 5 plus 2 does add up to 17. So there are a couple different ways to factor. One of the ways that I do is I still make my factor pairs, 1 and 20, 2 and 10, 4 and 5. Once again, those are my only choices. The easiest way to factor this is just guess and check. I mean, I can't take that long. We have 3x and an x. That's the only way we're going to get 3x squared. And we only have 3 choices. A little bit more than that because positives and negatives, but you can just guess and check a couple times and move them in. Like I'm not going to think that the 1 and the 20 works, so let's just start in the middle here, 2 and the 10. So I'll put a 2 here, a 10 there, and see if that works. Well, that will give me 30x, and that'll give me 2x, and that's not going to work. 30 and 2, that's never going to get me to the 11. So I'll back off and try different numbers. So let's try the 4 and the 5. Let's put 4 there and 5 there. So that's 15 and that's 4. Hey, wait, 15x and 4x, that's going to get me the 11x if I put the negative sign in the right place. So I need negative 11. So let's make this one negative and this one positive, and let's just double check here. So 3x times negative 5 is negative 15x. Or I forgot this one, 3x squared, which is right. And then this one is plus 4x, and this is minus 20. Everything works. Negative 15, okay, so 3x squared minus 11x minus 20. So I just checked the work, so this is the right answer. And it didn't take me that long to guess, just a couple times. But let me show you a second method. So because the 3 is messing with the 20, instead of making factors of 20, let's have factors of 60 and see what those are, and we'll use those, and I'll show you how. So factors of 60, 1 and 60, 2 and 30, 3 and 10, 4 and 15. Golly, there's lots of them. 5 and 12, 6 and 10. I did this in the wrong. 20. Okay, so lots of factors. What we can do, though, is split this polynomial up using factors of 60. Do any of these, can you see any of these adding up to negative 11? Yeah, these add up to negative 11. So let's use this pair here, and we're a couple steps away. 3, let's just rewrite this, 3x squared. Now instead of the 11x, let's write this as minus 15x plus 4x. So you see, I didn't really change it. I just wrote 11x as 15x and 4x, negative 15x and 4x. Okay, so this polynomial that we have now, we can factor by grouping. Let me clean this up. Okay, so we just took the negative 11x and wrote that into two factors of, well, 3 times 20 is 60. And so let's do the next step. Here we have to look for common factors by pairs. So we'll look at the first two terms. They have a 3 in common, so let's write this by factoring out a 3. Well, they have a 3x in common. Let's factor out a 3x. So take a 3x out of there, you have 1x left, minus 5. Let's do the second pair of numbers and take out their common factors. And they have a 4 in common. And look at this. We have now an x minus 5 in both terms. So we can pull out the x minus 5. And let's see what we have left. If we take out this x minus 5, we have a 3x left. We take out this x minus 5, we have a 4. So this is how it's factored. Honestly, this is a little bit of rigmarole, and it's probably just as easy to guess and check. So let's just do a couple more examples using the methods we talked about here. This first one has some common factors, so let's take out a 2x. And looks like we have x squared minus 9. Oh, that's a difference of 2 squares. We recognize that as an x plus 3, x minus 3. The next example has a common factor as well. And since this has a term that's negative, and I'm gonna actually factor out a negative 2 instead of a regular positive 2. So I factor out a negative 2, see what we got left. So taking a negative 2 out of that's negative 18. Taking a negative 2 out of that's positive 7x. And taking a negative 2 out of the last term makes it plus x squared. So let's move things around. X squared plus 7x minus 18. And then now it looks normal, and I can factor it. I don't like factoring when it's not in standard form. Okay, we know there's an x and an x, so we can get to x squared. We know that the factors of 18 are 1 and 18, 2 and 9, 3 and 6, and it looks like the 2 and 9 will get us to the 7. We need a positive number, so let's do positive 9, negative 2, that'll get us 7. Plus 9 minus 2. There we go. And the last one, we have no common factors. Okay, so we have to go like this. Oops, that's just a regular x. So it starts like that, so we can get to 2x squared. That's the only way we can get to 2x squared. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. So I'm just going to guess and check. Let's try the 1 and 12. 12. Let me see, that's 2x and negative 12x. That's close, but that's no cigar. And so let's try the 2 and 6. By the way, I could switch the 12 and the 1 around as well. So 2, 6, so that's 12 and 2. That's still not right. And let's try the 3 and the 4. By the way, I know I'm not going to put a 4 there, because then we would have a 2 and a 4 here, which means that we would have a factor of 2 that I could take out. I'm not going to do that. Let's put the 3 there and the 4 there. So we have 8 and 3. 8 and 3 gives us 11. Okay, but both of these have to be negative, so that negative times negative gives us a positive 12, and negative plus a negative still is negative 11. So you can check this, but that is the way that factors.